Okay, so so Lauren Edward from British American Tobacco, BAT. So going to be speaking you through emissions and consumer behaviour for tobacco heated products, specifically in Japan. So this is the 9-step framework that BAT kind of works all of assessments off of. It's a weight of evidence approach, so steps 1 to 9, starting at combustion studies, emission studies, toxicology, consumer behaviour, clinical studies, PK and exposure, individual risk and population modelling. So the two that I'll focus on today are emission studies and use behaviour. So use behaviour is really important for making sure we know how consumers are using the products, not assuming they use them similar to they do as they would with a cigarette. And the emission study helps for us to be able to base that consumer behaviour in the labs. So an introduction into the study itself. So the study that we've done previously, we've done Glow studies. So the original Glow product, which we refer to here as 2.0, produces an aerosol that's lower levels of toxicants compared to a cigarette smoke, and therefore has a potential to reduce the health risk in smoking. Japanese market is a very big THP market, and they've seen a big reduction in their cigarette consumption on that basis. So Glow, over the many years it's been on the market, has evolved in design. So this is heating changes, heating profile changes, and consumable formats. So from a scientific perspective, we need to make sure these innovations aren't affecting the original evaluation of reduced risk. So recent studies have suggested that a bridging approach, making sure that that variant is comparable to the next one to be able to reduce that science and make sure that it's comparable to the original claim. So the primary objective, you can see the original Glow on the left-hand side and then the new Glow Hyper device on the right-hand side, both of which were in market in Japan at the time, where we're looking at puffing topography, estimated mouth level exposure, and average daily consumption. So there's two products, but you can see there's 3 lines on the left-hand side. So you have the original Glow, so that's just one heating profile and in a king-size super slim format. And Glow Hyper in the base mode and boost mode, so these are different heating temperatures in the demi-slim format, so the tobacco weight is slightly higher. The study design, so this was a randomized control study design, looking specifically at Tokyo in Japan. So the recruitment was for 64 subjects aged 21 to 64, regular Glow users of more than 5 sticks a day for the last 6 months, and they're not trying to plan on quitting tobacco or nicotine, and they're willing to use the study products. So the participants came to a central location testing where they were signed their informed consent, and they were distributed the products for their home use testing. The home use testing period was between 5 and 7 days. This is important to make sure that we collect data from people's everyday environment, not just in labs. So they completed a daily consumption diary where we were able to look at their average daily consumption and average weekly consumption. Following this, they came back to the central location testing where we were able to monitor their puffing topography and mouth level exposure using a desktop puffing analyzer. This is puff count, puff volume, puff duration, and puff interval, and session length. And we can look at the mouth level exposure for nicotine and MFDPM. And this is 2 replicates with a sensory questionnaire as well. So this is the study design. So looking at the emissions, so the emissions here, I won't go through it all, but the WHO obviously recommend the 9 toxicants of concern for cigarette smoke. So on the left-hand table, you've got Glow looking at an overall reduction of 97% and Glow Hyper around 95% compared to a cigarette. So you can see there that the top-ranked 9 toxicants relative to a cigarette are significantly reduced, but also comparable between the THP products. On the right-hand side, you have other smoking constituents, so NO, NOx, nicotine, MFTPM, and TPM. So you'll definitely notice that the nicotine and TPM are higher. They wouldn't be what we deem comparable, but that's because of the tobacco weight that I mentioned earlier. So there's more tobacco weight, so we would expect them to be an increased amount of nicotine and amount of aerosol that's produced. So moving on to the puffing topography, so this is what we measured in the central location testing aspect of the study in Japan. So you have puff number, volume, duration are the main components of puffing topography. There is a difference in the puff number and session lengths, and that is consistent with the difference in the heating time. So the devices have different heating temperatures, and there's larger puff volumes and lower pressure drop, and the effort for the Glow Hyper device. The demi-slim consumable format, so for the Glow Hyper compared to the smaller diameter of the king size super slim. So moving on to ADC and estimated MLE. So this is where we get really enriched data from consumers when they are at home. So the ADC, so this is based on their sticks per day. You can see across the three products, so you've got 10, 9.6 and 10.2. So they were all within a meaningful difference. So for Glow, a meaningful difference would be deemed 1 stick. Anything less than 1 stick is not a meaningful difference. The estimated MLE for nicotine and NF-DPM as well, you can see here, and they are comparable. Slightly higher for the Glow Hyper, but within the expected range. And the estimated MLE to NF-DPM per stick under the standard puffing regime as well, you can see on the left-hand side. So in conclusion, the change in typing of heating mechanisms, so there's different heating mechanism, heating modes and consumable format across the different formats, they are deemed what we would call bridgeable, so back to the original full 9-step framework. The overall reduction in the toxicants relative to a cigarette are similar between the two Glow variants in the Japanese population, and estimated MLE to NF-DPM observed is similar to the yields generated in the lab. Which is the ISO standard of 55230, and it represents human behaviour, which is the main point of doing these studies. So this in turn indicates that the percentage reduction in the TOPOGRAPHY 9 is actual to human use and the variants are deemed bridgeable. Thank you.